Thank you, Alex, for the introduction. Good afternoon, everybody. Welcome again to Bentley's Success Factor Special Interest Group workshop. Today, we are going to talk about what is new in LibBridge Concrete Connect Edition version 17. My name is Xin Lu. I'm the product manager for LibBridge Concrete. As you have already known, LibBridge Concrete is Bentley's solution to everyday concrete bridges, which basically cover small to medium concrete bridges of all types, including precast, cast in place, reinforced, pre-tension or post-tension. LibBridge Concrete offers an integrated, all-in-one solution of geometric modeling and analyze design and load rating in a single information-enriched environment. In the past few months, we had 3 releases, 2 of which were main releases with a number of new features added, and 1 was a maintenance release to only address some important issues. Please go to Bentley's community or check on the RSS feed through the link inside LibBridge Concrete for the detailed release notes. So the purpose of this workshop is to provide you a quick review of those new features. Here is our agenda today. First, I will go through the main enhancements, including the merging the LibBridge Concrete library files from either the old component product libraries or from the new consolidated LibBridge Concrete library. The feature of multiple units allow you to model, analyze, and design bridges with 2 or more thermal units in superstructure. Transition pier typically goes hand in hand with the feature of the multiple units. Stepped cap allow you to model stepped cap in a full bridge in the main module and subsequently analyze, design it in substructure module. 3-point bearing system allow you to define a unique bearing layout through the ABC Visor, where 2 bearings are used under one girder at the beginning of span and only 1 bearing under one girder at the end of span. Texas DOT option is a feature which we worked closely with Texas DOT and implement in order to comply with the requirement of the bridge engineering practice in Texas. In addition to above major enhancement, I will also briefly talk about the additional enhancements, including a couple of minor enhancements regarding the response spectral analysis and the support of new beam types for Maryland DOT, Illinois DOT, Idaho DOT, Pennsylvania DOT, PennDOT. I will also talk about the new 3D graphic viewer we recently adopted in LibBridge Concrete, and the 2 connect features which will considerably improve user experience with LibBridge Concrete. We will have the Q&A session at the end. Let's take a look at the main enhancements. Merging LibBridge Concrete library files. This is an extension of the consolidation of LibBridge Concrete. This feature has been requested by quite a few users, including Ohio DOT, PennDOT, and Georgia DOT. Basically, 2 types of the merging are offered. One is merge from the old lib component libraries. In the main module, if you click the tool menu and merge component libraries as highlighted here, a window will pop up. And there are 14 on the right. You can see there are 14 component libraries which are from the old lib component product, such as ConSpan, RCPeer, ComBox, etc. You may choose merge or complete override option when it comes to a situation where there are common items in both merging and merge libraries. A default option is merge. The other type to merge from the consolidated library is to merge from the consolidated library. In the main module, you can check click the tool menu and merge the consolidated library. A new window will pop up asking for the consolidated library file names on the right, as shown on the right. Then you may specify what file you want to merge into the current LibBridge Concrete library. Multiple units. This is a feature requested also by a few users, including Mississippi DOT and Arkansas DOT. Basically, this feature requires the multiple thermal units being used in a bridge. Those units may or may not have are the same unit type. So here is how we do it in LibBridge Concrete. First, in the precast pre-stressed girder module, you need to select multi-span mixed from the pull-down span type under the project tab. Then you need to go to the geometry tab and input the unit data as needed. Then you click the edit multiple span button, and the multi-span window will pop up, and you need to assign the spans to the corresponding unit numbers. Here is a typical moment diagram due to the live load in a multiple unit superstructure. You can see here, unit 1 is a continuous 2-span unit, and unit 2, on the other hand, is a long continuous 2-span unit. Transition pier. So what is transition pier? Simply put, a transition pier is a pier connecting two thermal units. This feature goes hand in hand with the multiple units. In this particular example, you can see here the unit 1 is a 2-span continuous unit, and the unit 2 is a 2-span non-continuous unit. So the bent number 3 here is a transition pier connecting unit 1 and unit 2. If a pier is a transition pier, then there is an extra information in the span table, in superstructure, parameter window, and the extra information including unit number and the unit type. The transition pier is just like the other other types of piers, except two things: dead load and the live load effects from the superstructure must be generated from the analysis in superstructure module in LibBridge Concrete. The integrated workflow, meaning the reading the force reactions of the dead load and live load from the superstructure module, must be used in substructure module. Other than that, those two, the design and the code checking on transition pier will be the same as other type of piers. Step cap. So this feature was originally requested by Mississippi DOT, but we made it available to all the bridge concrete users. The main module, you can see here, at the step 2 of ABC wizard, if you select the auto compute stepped cap, here you will see the sketch of the steps showing on the bent cap. You can see here. After you click the button Customize the steps, a window will pop up allowing to input a minimum height of the step, minimum height increment of steps, and the step height rounded up to, as shown here. Based on what you input, the program will automatically calculate if the steps are needed or not, and lay out the steps on cap top accordingly. In the bearing step window under Substructure tab, you will see the detailed information about the automatically generated steps. And you can manually adjust those dimensions of the steps. Now we go to the substructure module. You will see the step type is actually chosen under the cap shape accordingly. In the step cap parameters window, you will find more details about the geometry of the step and the 3D model of the stepped cap is shown here as well. Three-point bearing system. This feature allows you to lay out a double bearing under a beam at the beginning of span and a single bearing under a beam at the end of span. This was originally requested by Texas DOT, and we made it available for all bridge concrete users. Here is how we do it in the program. In the main module, at the step 1 of the ABC wizard, if you select certain types of girders, here we select open box. Other types include slab beam, hollow core, cellular concrete box. The option for 3-point bearing system will show up underneath here. If you click the definition button, a new window will with detailed explanation will pop up. What you need to do is just need to specify to input the offset of the double bearings. Here we inputted the 12-inch. Back or offset. This feature also was original requested by Texas DOT, and we made it available for all users. The first case you can see here is for the pile cap abutment. Basically, you may move the back wall along bridge's longitudinal direction by changing the offset of the back wall. Another case here shows here is the case of the related to stem wall abutment. Also, you can move the back wall basically along the bridge longitudinal direction. Distribution of reeling weight. In the past, the bridge concrete substructure module only offer equal distribution of dead load due to barriers. So per request by Texas DOT, so we now offer for all users the customized, or we call that a user-defined percentage. This is previous. This the new user-defined percentage distribution of the barriers load up to the 3 exterior bearing groups. We have mentioned Texas DOT like a request for a few times so far. In the substructure module, under state specifications, you can find the Texas option here. In the following slides, those are features which we implemented specifically for Texas DOT if this option, Texas option, is selected. Let's take a look at them. For the self-weight and customized load combinations, so when the Texas option is selected, the self-weight will show up as a new load type, and the customized load combinations will be automatically selected for analysis by default. Again, when the Texas option is selected, the individual live load cases in the summary report will be replaced by live load envelope results. Here in the printing window, so you need to check the live load envelope results, and then you will see the live load envelopes. When the Texas option is selected, the result of the cap and the columns will be separated. So in the printing window, you need to check this envelope combinations for cap. Then you will see the envelope results for cap only. Then for column and drill shafts, you need to check the envelope combination for column and shaft, and then you will see the result for column and shafts accordingly. This web shear cracking check, this is additional design check requested by Texas DOT based on the research carried out by UT Austin. So it's essentially a serviceability check of concrete deep beams. So basically, this additional check will check the web shear cracking, particularly for straddle band in Texas. So here is how you do it in knee bridge concrete. In the AD parameters window, so you need to check the box shear limit check on cap of the straddle band. This box here. This is a preferred an analytical model by Texas DOT. In this typical multi-column pier, the preferred analytical model for the pier, the cap is treated as a continuous beam, basically pin at the top of the column. So in knee bridge concrete, if you check the substructure module of the pier, you will find the hinge is used at the top of the pier column, as shown here. There are some additional other enhancements for Texas DOT. They include they are preferred concrete default concrete strength is 3.6 KSI. The preferred offset of the face of support is equal to the column diameter, and the preferred breaking load is bigger of the 5% of design track plus main load, or 5% of the design tandem plus main load. So we implemented it for Texas DOT. If a user selected that Texas option, all those are configured automatically for the Texas to comply with the Texas bridge engineering practice. So far, we covered the main enhancement in the bridge concrete. In the following few slides, let's take a look at the additional enhancement. Response spectral analysis. This work is an extension of the previous development efforts on response spectral analysis. So basically here, Liquid Concrete offers an option to exclude the participation of the abutment in the response spectral analysis. This is how you do it in Liquid Concrete. So in the main module, select the response spectra from the analysis option pull-down this menu. After this response spectral analysis is selected, a typical, let's see, this is after this option is selected, and a typical mode shape of the whole bridge is like this. Clearly, you can see here the abutment do not participate in the response spectral analysis here. In the response spectral analysis parameters window, we add load and save buttons, basically allowing you to direct and maintain the design response spectral files in a much convenient manner. We added a number of new beam types into our Bridge Concrete library. For Maryland DOT, we added 24 next beams. For Illinois DOT, we added 11 new Illinois beams. For Idaho DOT, we added 2 Idaho wide flange girders. For PennDOT, we added 28 adjacent box beams, 75 new PennDOT eye girders, and 28 spread box beams. The new 3D graphic viewer, the new 3D graphic viewer is based on the new graphic engine. We call that a visualization toolkit, VTK in short, which provides a more flexible visualization tools and a better user experience. This is how a superstructure looks like in 3D viewer in the precast pre-stressed girder module. This is how a substructure, a typical substructure looks like in the substructure module. Last but not the least, we added 2 connection features. The first one is a connected visor, as Alex mentioned at the beginning. So this feature allows you to basically to get access to the relevant help on Bentley communities, Learn server, and YouTube right from a single location within the program. And another one is the feature is a connect updater. So this feature basically allows you. This feature basically includes a notification service from within the connection client that automatically notify you when the new versions are available to download and install. with that, I finish my presentation, and thank you for your attention.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.